So this video is on 1-47 to 1-50. Again, I want you to try these problems without the video first and then come to the video for help. On this first problem, it says, which of the relationships below are functions? If a relationship is not a function, give a reason to support your conclusion. So just as a little reminder, a function, each x or input goes to one and only one y or output. So you can't have one x going to two separate outputs. Now, on this first one, it is a graph. So what we're going to use, I'm going to kind of zoom in here, is we're going to use what we call the vertical line test. And so I drew a vertical line using my line tool here. Okay, I made it a little fainter so we could see through it. And now what I'm going to do is I'm going to move it across this graph. And as I move it across this graph, right here, for example, I'm testing if x is -3. Here I'm testing if x is -2. Here I'm testing if x is 1. So as I'm moving this, everywhere I move it, I'm testing a different x. So for example, right here, okay, I see that for this particular x, I have it touching 1 time, 2 times, 3 times. That means that that particular x has 3 outputs, 3 different outputs. We cannot have that happen. So this is not a function by the vertical line test. The vertical line touches the graph at more than one spot. I should say point. Okay, looking at the next one, the next one's a table. So for the next one, I'm going to be thinking about it as this right here. Each x goes to one and only one output. So as I'm looking at my x's, -3, 5, 19, and 0, each of these x's is not repeated. -3 only goes to 19. 5 only goes to 19. 19 only goes to 0. 0 only goes to -3. Don't be concerned about this 19 and this 19. I can have each of my x's go to 19. That's not a problem. I just cannot have -3 go to 19, for example, like it does, and then go to some totally different number. That would be a problem. So this one here is a function. And so I'm going to say function. Each x goes to only one y. So again, when you're looking at it and you're looking at your x's, and if none of your x's repeat, it's automatically going to be a function. I don't even care what's on the other side for my outputs. Automatically going to be a function. Okay, next one. Okay, on C, we have another table. Now, in this situation, I do notice right away that I have a 7 here and a 7 here, okay? So since I have 7 going to 10, and then 7 also going to 3, this is not a function. The input 7 has 2 different outputs. Ten and 3. And that cannot happen. So on letter D, which is a graph, for a graph again, I'm going to use the vertical line test. And so I'm going to grab this vertical line, and everywhere I move this vertical line across this whole entire graph, if anywhere it has more than one place it touches, it's not going to be a function because that X has more than one output. But no matter where I put it, it's always going to only cross once. So function by vertical line test. Everywhere the vertical line moves across the graph, it only touches at one point. So on 1-48, they want us to find the x-intercept, which is where the graph crosses the x-axis, and the y-intercept, which is where the graph crosses the y-axis. And they want us to find them for each of the situations above. So I just kind of cut and pasted the graph. So let me just kind of get it back here. So we can just kind of see it here. So this one is letter A. So on letter A, if I'm trying to find the x-intercept of this, okay, I want to figure out where it's crossing the x-axis. So as I'm looking at this, it looks like it's crossing the x-axis at this point here and this point here. So at 1 and at -1. So okay, at 1 and at -1. I'm just going to move this. So this is going to be at 1, 0 and -1, 0. I'll just get rid of this. At 1, 0 and -1, 0. We want to write it as a point so that we see a relationship, okay? Now for the next one, we want to find the y-intercept, okay? So for the y-intercept is where it crosses the y-axis. So if I draw a line on the y-axis, you see it crosses here, which looks like at -1, and here at 4. So that point's going to be 0, -1, and this point's going to be 0, 4. So that's what I'm going to write, 0, -1, and 0, 4. So 0, -1, and 0, 4. Okay. Now, just using this kind of as an example, I'm going to move this back up. When I am trying to find an x-intercept, notice that as I'm going across the x-axis, any point on the x-axis, this point here is 0, 0, 1, 0, 2, 0, 3, 0. Going the other direction, -1, 0, -2, 0, -3, 0. All of my y's are 0 on the x-axis because the height of these points is at a height of 0. Going up on the y-axis, this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So each of these are going to be 0, comma, some number. Okay, so that's what we want to pay attention to. So let me get rid of this. Okay, so the next one, we're going to be looking at the table. So let me get, so if I'm looking at the table here, I'm looking for certain points that are going to be special. So my x-intercept, I need to have my y being 0 because both of those have a y being 0. So my y is 0 here. So that's going to be my x-intercept, 19, comma 0. So 19, comma 0. And then my x-intercepts, I'm sorry, my y-intercepts over here both have my x being 0. So I'm looking for my x0, which is right here. So that is going to be my y-intercept, which is 0, comma, -3. Okay, so again, we're looking for where my y is 0. That's my x-intercept. We're looking for where my x is 0. That's my y-intercept. So let's look at the next graph. So here I have my table. And what you want to notice is that my x-intercepts, my y is 0. So I'm going to be looking to see where my y is 0, which is here and here. So I am going to have this one here and this one here. So my x-intercepts are going to be at -2, comma 0 and 4, comma 0. Then when I'm trying to find my y-intercepts, my y-intercepts have my x's being 0. So right here, this is where my x is 0. So that is going to be at 0, comma 10. So on letter D, okay, this one here is letter D. When we're trying to find our x and our y intercepts, okay, again, our x-intercepts are where it crosses the x-axis. So on D, it looks like it crosses here, which is at -1, and here, which is +1. So I'm going to have -1, comma 0, and I'm going to have 1, comma 0. Then my y-intercept is going to be right here because that's where it is going to cross the y-axis. And that point is going to be at 0, comma -1. So x-intercepts, notice again, all of them have a y that is 0. Y-intercepts, all of them have an x that is 0. Okay, next problem, 1-49. We have this pattern. It says the growth rate of the pattern is what? So looking at this, what I like to do is I like to count. So let me just go 1, 2, 3, 4, 5, 6, 7. So this one has 7. 1, 2, 3, 4, 5, 6, 7. So that was the original one that I just had. When I say original, the second one. 8, 9. So that's going to be 9. So now if I take this last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, then this is going to be 10, 11. So you see I'm adding 2 every time. I added this 2 and this 2. So if I'm going backwards like they want here, where they want us to sketch figure 0, basically these 2 would have been what's added on. So if I'm trying to draw this, I would end up having a situation where I have 1, 2, 3. Let me make it. And then I have 2, 3 here total, but so that would end up being, if I shade over here, this right here that I'm shading in yellow should be that. It asks us what the growth rate is. How many are we adding each time? So I'm adding 2, I'm adding 2, I'm adding 2 each time. So my growth rate is adding 2. And then if we're trying to figure out what figure 8 is, so a couple things you could do. We could do a table here, and we figure 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can continue that pattern. That's one way to do it. So this one had 7, then we had 9, then we had 11. If we keep adding, we're going to have 13, 15, 17, 19. So 19. Now, eventually, we want to not have to be making a table every time. So if I was going backwards, 1, 2, 3, 4, 5, you can see I had 5. Here, going backwards, I had 3. So another way to do it is eventually what we're going to be doing is we're going to be finding our start, which is this. The 0 is 3. We're starting with 3. We're adding 2 over and over again, x times. So in this case, we're starting with 3. We're adding 2 8 times. And you see I get 3 plus 16, which is 19. That's eventually how we're going to want to start doing it, but it's okay to do a table. On 50, solving equations, okay? So when I'm solving equations on the first problem, I've got like terms here, so I'm going to combine like terms. So I'm going to get a 3 minus x is equal to 10. I am then going to minus 3 from both sides. Now you got to be careful. You have to bring down this negative x. Okay, and then on this side I get a 7. Now, I do not want a negative x. So a couple of ways you can think about that. That's a negative 1 in front, so I'm going to divide both sides by a negative 1. When I do that, I'm going to get x is equal to negative 7. Another way to think about this is if this is a negative x, make both sides opposite, so that's going to become a positive x. Then make the other side opposite, which is a positive 7. It's going to now become a negative 7. On the next one, I am going to minus 300 from both sides. And I get 100x is equal to a negative 100. I divide by 100, I divide by 100, and I get x is equal to negative 1. Now, some of us might have noticed in this problem, when I have 100x plus 300 is equal to 200, I could really divide everything by 100, and this would be an x, this would be a 3, this would be a 2. Then I work it out, and you see I get the same answer, negative 1. Eventually, we're going to be doing problems like that. On C, I'm going to get my x's on the same side, so I'm going to minus x from both sides. I'm going to get 12x plus 4 is equal to negative 2. I'm going to minus 4 from both sides. So I'm going to get 12x is equal to negative 6. I'm going to divide by 12, and when you divide by 12, it's a negative 6 over 12, or it reduces to a negative 1/2. On this one, I could either add x or add 2x. I'm going to add 2x. So I'm going to get 36 is equal to x plus 2. I'm going to minus 2 from both sides, and I get 34 is equal to x. And that's my answer.